Okay, so as we were just talking about, we're going to go through this example of how to extract the environmental values from your sampling points. And then we're going to create a bunch of random points across the study region and extract the environmental values at those random points. And then we're going to visualize them and see how well the study area has been sampled by the environments in the study area have been sampled by the occurrence points. So the first thing that you need to do is pull up your environmental layer that you want to look at. So we'll start with precipitation. And this is the interpolated surface that I was just showing you from the other PowerPoint presentation. And so the next thing that you're going to do is go ahead and overlay your occurrence points or your sampling points on top of your environmental layer.
Those are the points for the shoebill.
Yes, these are the points where the shoebill stork are located. So once you have this information, then you need to extract the environmental values. So we're going to extract the precipitation values that are located at these shoebill stork occurrence points. And you use the point sampling tool in QGIS to do this. And don't worry about the details right now of exactly where you need to go in the program or what you need to click on. Just kind of get a general idea of the process that we're using. So the town's going to create a new shapefile that will have the location of the occurrence points in it and the environmental values, the precipitation values at these occurrence points. So if you look at the attribute table for the new shapefile, then this environmental variable for precipitation is called bio12. And so at each of these locations, and you can see that there's 1,209 millimeters of average annual precipitation at that location. And so there's going to be one value for every single occurrence point that we have.
And they go from 1,887 up to 1,571.
So the next step then is to go ahead and create a bunch of random points across the study region. So when you're thinking about the number of random points, this is kind of subjective because you're just going to get a visualization of what's going on in the area. But you want to think about the resolution of your environmental data set. If it's really fine, then you may want to use more points. If it's coarser, you can use fewer points. And you also want to think about the size of your study area. So if it's really large, you want to use more points, and if it's relatively small, you can use fewer. And so we're going to use just about 1,000 points to kind of get an idea of what's going on in this region. So town's going to create random points within the boundary of Uganda. So you would be using your study area boundary as the boundary that you want to create these points within. So he's going to make a new shapefile that has the latitude and longitude for each of these new random points.
Please notice, Sean, that if you wanted a stratified sampling design, there's your opportunity.
Okay. Yeah. So you can see these are just randomly placed across Uganda, and there's 1,000 points. It looks like it has a pretty good distribution across the region. So the next thing that we're going to do is go ahead and extract the precipitation values to these random points that Town just created. So we're going to follow the same method as before using the point sampling tool.
Can I throw in
You want to put in the other one?
temperature as well?
Yeah. So you can actually pull the environmental values from more than one environmental layer inside of QGIS. So he's going to just combine this process and take the environmental values for temperature at the same time. So we'll have two columns at the end, one for precipitation and one for temperature. Oh, okay. So now when you look at the attribute table for the 1,000 random points, you can see that there's environmental values for precipitation, which is called Bio 12, and also for temperature, which is called Bio 1. And both of these are the mean annual values for these locations. And it has a much larger range than the occurrence data points that we were looking at before. For Bio 12, it goes all the way up to 2,119 millimeters. I think for the occurrence points was at 12 something, 1,000 something. And then there's, on the low end, there's 541 millimeters of average annual precipitation. So the next thing that you want to do is kind of take a look at these points and see where the environmental values at your sampling points fall within this overall general range of environmental values in your study area. Were you able to extract the temperature for the sampling points yet? Okay. Is this making sense so far to everyone? The general process and
Please listen.
yes?
I have two variables taken from the GCM.
These variables are, you mean from a general circulation model? Actually, this data set is compiled from a whole bunch of weather station data, and it's interpolated across the surface, and so it's from 1950 to 2000, I believe. And so they took the annual values of each of these annual average values and then came up with an overall annual average for these locations, and then created the interpolated surface where they estimated in between the points to get the gridded surface.
Okay.
So that's why it's at a little bit finer resolution. The GCMs, the general circulation models, tend to be coarse. You can use different methods to make them downscale to a finer resolution, but you have to be a little bit careful when doing that for reliability of the values.
And which method of interpolation did you use?
So actually, I think they used some kind of, did they use a spline, a B-spline, so they didn't use Kriging. But the B-spline, they took into account topography. So if there's a higher elevation in an area, elevation tends to impact the value of temperature. So they accounted for elevation as they interpolated across the surface.
Because most of the time in geostatistics you use Kriging.
Right, yeah. And there's different kinds of Kriging that you can use, yeah. Right.
What, environmental data out to
Visualization, yes.
Okay. That's not it.
I can send you the link, Rodrigue, to this data set, and you can read about the methods that they used if you're interested. Yeah. So right now, Town's going to export the environmental values at these locations for the sampling points and for the random points, and then we'll create some plots to see where the sampling points fall within the environmental data. And he's already done this. So
Notice that we have 69 points for shoe bills, but for environments we had 1,000.
Okay. So if you didn't hear what he just said, there's 69 points for the shoe bill stork, and then there's 1,000 points representing the overall environments across Uganda. Do you want to kind of describe what's going on in the plots?
Okay, so all I'm going to do right now,
I'll just give this to you so you can.
just if it's there, it'll pick me up.
Okay.
So first, let's look at the shoe bill points. And I'm going to put precipitation on the y-axis. And, sorry, that was the x-axis, wasn't it? And I'm going to put temperature on the x-axis. So there's a plot of temperature versus precipitation for this species. Okay, and so this is the wettest area, and this is the hottest area, and this is the coldest site, I should say. Now, let's go and get the second data set so that we can see what the availability of environments looks like across Uganda. Problem that one is on top of the other. Of course, I can't change the order. So I'm just going to add another shoe bill. And so now you can see a profile of where that species has been found. Okay? The important thing is you can see it in the context of the environments. One very, very common feature of environmental profiles is that they have weird outlines. So look at this thing that has that spike going up and that spike coming over here. Let's interpret those. What does this point look like environmentally? Very high precipitation and very cold. So where is that? Mountains, yes. And this point is very high precipitation, but fairly warm. Lakeshore or possibly rainforest. And then over here and down here, those are desert. Okay?
Yeah.
Now, in QGIS, I don't think you can link the plots. You know, ideally, we would outline some piece of this and see it on the map. Okay? In fact, maybe I should,
Should ask Jeff.
Diva GIS.
Oh.
shows it. Anyhow, that's an ideal thing because you can link. Maybe I can give you a demo of that later on in a different program. So these points could just as easily be the sites that are well surveyed. And so what we're after when we talk about environmental distance is, imagine that each of these points is our well-surveyed sites that we're identifying in each of your projects. So then an environment right here at the tip of the arrow is not very different. A site there is not very different environmentally from other sites that have already been surveyed. But this site is very, very, very different. Okay? And remember what I told you, that these environments may be very rare. And so a random point might miss them entirely. This is one of those cases where one of our points, 1 out of 1,000, got way up in the mountains. Okay? And so even though that might be just 1 or a few pixels across Uganda, the environments are so different that sampling there might be very worthwhile. Or here, or here. Those are environments those are sites with environments that are very different. So just the way Arturo talked you through temporal gaps and spatial gaps, here we have environmental gaps. Okay? So for about half of the projects, we've derived the spatial gaps. Next, we will be deriving the environmental gaps. Okay?
Which unit is the temperature?
This is
Millimeter, or sorry, temperature is actually, it's in Celsius, but it's been scaled to make it, it's been multiplied by 100, or 1,000, no, 10, sorry, by 10. Yeah. Just so there's not decimal places. It makes the file much larger with the decimal places, so they, yeah. I know that's confusing when you see it.
Any questions about environmental gaps? Okay. Kate, you want to kill the camera?
Yeah.
Which criteria guide you, or how do you choose the resolution of a variable? How do you know, oh, it might be coarse or it might be fine?
Right, so that's kind of actually one of the big questions in geography when you're looking to set up your research design. And so there's different quantitative methods that you can explore to see whether or not your resolution might be meaningful. But also I think that the main thing to think about is whether or not, for example, with plants or insects, is a microclimate really important to your species? Do you see a lot of variation in where it's located, in very small areas, or is it just kind of broadly distributed? And that can help you to decide what resolution you might want to look at. But unless you kind of explore these different extensive quantitative methods to look at what might be a good resolution, it's it's always kind of subjective. And so even when you're writing a proposal or something, it's challenging to, you have to justify the resolution. It's challenging to know ahead of time what the best resolution might be. So I guess just think about what's most biologically meaningful to your species that you're looking at.
So on a more practical note, you might also not go to a finer resolution than the precision of the data. Okay, if your occurrence data or your sites are defined at a fairly coarse resolution, then you really don't want to look at environments at a finer resolution than that.